Thank you for coming to this meetup about. So I'm going to talk about p2sh.info, which is a website I've developed over the past 4 years, and which specializes in Bitcoin data analysis and extracting information out of Bitcoin blockchain to get insights into it. So who am I? I'm Antoine Le Calvez. I currently work at blockchain.info on charts and data. I created p2sh.info, as I mentioned, and also forks.network, which is a child of p2sh.info, which specializes in analyzing the split between Bitcoin and Bitcoin Cash, and later on I added also Bitcoin and Bitcoin Gold to see what can we learn from it as well. I also create and contribute to open source software. I open source some part of an old code, part of the code base of p2sh.info, which is the Python Bitcoin blockchain parser module, which gives you an API to read the Bitcoin D files where the blockchain is stored, and to get it in Python in a way you can do anything with it. And I've recently did my first pull request that was merged in a Bitcoin core, so that's exciting. Maybe there will be more, hopefully. So what is p2sh.info? So it's a website to, as I mentioned before, to create and compute statistics about Bitcoin, generally in the form of charts. For example, how many Bitcoins are stored in op-written outputs. It started quite early in 2014. I learned about Bitcoin in 2013, but only got into it technically late 2013, early 2014. And I decided to do something about it, and I created this website. The origin, as the name implies, which name is a bit outdated now, it was to do a deep dive into p2sh, so pay to script hash, which gets abbreviated to p2sh, which is the Bitcoin smart contract. Some would say it's a way to pay someone with a generalized way, and that person can do then any kind of fancy, Bitcoin fancy, not Ethereum fancy, logic with it. For example, it's multi-signature, could be Lightning Network is all implemented using p2sh scripts. And I've actually written an article about this a few years ago about many other kind of ideas people used with p2sh. Some people did mathematical equations and kind of stuff. It's a bit funny. And now, as time went on and I got more curious and more learned more about Bitcoin, I added more and more statistics to it. It's got a bit of a a heap of charts, a bit randomly. For example, fee estimation, because during my work at blockchain.info, I dug deep into it and wanted to see what are other algorithms estimating and how does it compare, and I made this information public. So Lightning Network, when it comes down on mainnet, I released a dashboard where you can see how many nodes, how many channels, how many Bitcoin in these channels, which is interesting. Also technical changes to Bitcoin, like SegWit use, replaced by fee, all this kind of stuff gets charted and tracked. So the main component of p2sh.info is tracking how many Bitcoins are split between all the script types. So just a quick recap. In Bitcoin, you can send money usually to an address, but this address is a bit of a misnomer. It's hiding something from you. It's hiding it. You are actually paying a script, and the script is just a stack-based sequences of instruction that you have to provide a solution for in order to claim the money. So the most common one, the one we use for addresses, is the second one, pay to pubkey hash, where if the riddle is here's a hash, and if you can provide a public key that hashes to this hash, and then provide a signature that matches the public key, you can spend the money. The original one was pay to pubkey, but it was not deemed, it's not size efficient, and it's not as well quantum, I don't know the exact logic, but hashing the key makes it safer. There's also pay to script hash, as I mentioned, which is where you pay for anything like a multisig or Lightning channel. There's op-written, which is used to commit data to the blockchain. Before that, people would use weird schemes, like not fake, but addresses for which they didn't know the private key, multi-sig, weird schemes. And now people introduced op-written, I think already existed, but was not standard, and it was standardized later. And it's used, for example, for open timestamps. The Omni protocol, which Tether uses, also uses op-written to encode information. And then at the end of the list, there's the exotic ones. There's naked multisig. It's like BIP11 multisig, but I call it naked multisig. It's the original multisig in Bitcoin, but it's very limited. You can only do 1 out of 3 or 2 out of 3 or it only goes up to 3 keys, whereas with p2sh hash you can go 15 to 15, and with SegWit I think it's even more now.
Is that a consensus limit on the
script? Yeah. The script cannot do more than 3.
Well, what's the consensus limit on the script pub key that makes it?
So for p2sh hash you cannot. There's I think 2000 or 6.
No, I'm saying for bare or for naked multi-sig.
I think the limit is 3.
Yeah, I was just asking what is the specific consensus limit that restricts it to 3?
I think it's a question you have to ask Satoshi. I think it was this way already.
No, yeah, okay. I just want to know what in the code is the actual, because I know there are several different consensus and standardness limits for different types.
Yeah. I don't know actually for multisig.
I've never even used naked multisig. I just wondered. Just curiosity. Sorry. Go ahead.
And finally, there's a last bucket for any script which I couldn't parse or is really non-standard. And there's not a few people that use them. Most often it's actually bugs in software. Mongox lost 2,600 Bitcoin because I don't know how they fucked it up, but they did bad. And it ended up in a weird script which goes into this bucket. And there's also sometimes people doing riddles. There's bounties for opponent hash functions. There's an opcode which does a hash, and people basically pay to a hash, and if you can get the preimage whichever way, you get the bounty. And actually, for SHA-1, I think it was claimed.
Yeah.
Which was...
Wasn't it a collision, Rob? Was it a collision or was it a preimage?
I don't remember which one it was, but there was some bounty that was claimed with that. So these are these, and with these, and the SegWit versions as well. With all these types, we have all the Bitcoins can get assigned one of these, which is interesting and useful later. There's also, so why did I create it? There was no information about multisig and p2sh hash. It was in 2014. It was started to get used, but there was no one knew how much. You could go on forks.network and see, okay, if I open a block and I comment F, maybe you could try to do some manual statistics, but no one was actually looking into it. And also, I wanted to learn a bit more about Bitcoin. I knew programming, I knew Bitcoin. How could I get to mix these two? And that's how I started. So a bit of walk down the memory lane. This is the first version, where actually I think I spent more time on the design and the HTML and the CSS than I actually did on parsing the Bitcoin part, which I learned later that it's not a good idea. You should focus on what you know and let the stuff you don't know to other people. So you could see, for example, how when Bitcoin was sent to a p2sh hash address, which was, actually, you look at the timestamps, it's not very often. Like, that's nearly half a day worth of activity, and it's this many transactions, which nobody used it basically at the time. And also the amounts were not that big. I mean, 2014, that's like maximum like $300. And also when they were spent, saying, oh, it's a bit more, maybe a bit more activity, but was not used. The first number I got was that 0.028% of Bitcoins were stored in p2sh hash addresses, and now it's, I think, 25% or 26%, so a huge improvement on that. And now this is the version now, which, at least for me, is much easier to maintain because it uses Grafana, which is a software. You just run it, and it gives you a way to plug in into databases to display charts, which remove for me the need to maintain JavaScript and CSS and all this stuff that I don't really master. For example, the original website on mobile was not a good idea to load it, and now it works fine on all screens. And it also enables way more complex charts. For example, this one got a bit of attention in 2015, 2016, the whole midst of the block size debate, because it was a nice and clear visual way to see how congested was the blockchain. You can see when it's green, it means that there's not a lot of space in the blocks. When it's red, it's completely full. And the blue part was when SegWit kicked in. Blocks above 1 megabyte in base size are painted blue. And you can see that right when SegWit was activated, there was a lot of decongestion or wallets, because it's also coincided with the end of the bull run. People cleaning up the wallets, and after that you can see it's much clearer, and it's much spikier, because the extra block space gives time for example, there's a few hours in a day, midday London time, where there's a lot of activity, and then with bigger blocks, it gets processed much faster. The other way was spread from midday to like afternoon, late afternoon. Now it's much spikier. You can also see that in the fee estimation. Actually, it dates back to 2016, though you have 2 years of fee estimation data for that, which I think is quite a value for academics at least, to see how it improved. And we can see now, we can see the daily spikes when there's a lot of activity. I don't know if it's an exchange that does withdrawals or something.
Is that mycelium at the top?
Yeah, then I think they use, and that's actually where you can see the progress. They use the 2015, 2016 fee estimation style, like the one that was in Bitcoin. It was working fine for when the blocks were not full. But since then, and the big fee event or the fee rush we had in 2017, most of the people upgraded to this reactive kind of algorithm, which are based on the mempool. So how many transactions are waiting right now? They pay this much. Okay, so if I pay that, I go inside. Whereas this one looked at the past, and of course, if you look at the past, you're always too conservative, and you also don't react as quickly. As you can see, this transition, you can see when each algorithm kicked into the new version. If you look a bit closer in the data, and actually, blockchain.info was the first one, publicly at least, public API to use this kind of mempool-based algorithm.
Are those dates like this September?
Yeah, this year, yeah.
Okay.
So as you can see, it doesn't go very high. Like 20 such per gives you that's the fast fee. If you want to wait for half an hour or an hour, you can pay even less than that.
So Mycelium is using data from last year?
No, not for last year. An algorithm an algorithm which is too old and not adapted to the current ecosystem, basically.
So it doesn't pay attention to the mempool distinction.
Yeah. It looks. I don't know. That's my theory. I haven't asked them.
What's the scale of the y-axis?
Oh, it's satoshis per byte. So it's a size invariant unit. So it doesn't matter how big a transaction. It does matter, but it's the actually I should change it to satoshis per weight unit now. But it's the issue that not all APIs support it, so the conversion is a bit weird. And also the Lightning Network, which actually I think was the first website to have information on that. I think someone posted another website like 2 or 3 hours after, because it was the day when the mainnet was released. I was like, okay, I need to get it in, and I did it. It took me quite a while to talk with the C Lightning RPC API. I actually wrote a piece of software to expose it over HTTP, because by default they use Unix, so IPC stuff. So it's interesting. Like right now, it's 114 Bitcoin in it, which.
Wait. I was really interested in this one. What's your exact algorithm to pick up a channel you're looking?
There's an RPC call for C Lightning that, hey, give me all the channels you know.
Yeah. I'm sorry, I thought you were looking at blockchain. Yeah.
No, looking at the blockchain, you can only know when a channel is closed, and that's what I do actually to update this chart. C Lightning only gives you the ones it knows about. It never tells you when it saw one and never seen it again. So I had to know when it closes.
So these are publicly announced channels?
Yeah. You can't know. I could add the information. Actually, that's a good point. I could look at closures of channels that were not announced and add them back. That's a good. Actually, that's good.
So this is quite low down, because we've also got the issue that cooperatively closed. You can only kind of infer. You don't really know.
You can't really know. Actually.
You know, is it going 2 or 2 and then goes out with 2 or 2?
Yeah, but the script is. Actually, I don't remember. I need to look into it, but that's a good point. I could look at the non-cooperative case.
Yeah. What does the script look like when it gets spent from the channel out point?
I think that they're actually for cooperative. They actually.
They overwrite. Yeah.
They overwrite transactions, so you don't know that.
You're not going to. Yeah.
So
and of course, with two-party ECDSA coming too.
Yeah, I mean, actually, speaking about that, like, all the privacy tech will make a lot of this website irrelevant, which actually I'm totally rooting for. I don't want to be, because there's a lot you can learn by just looking at these high-level statistics, and I'll go into that later. So a bit about the technical architecture, like how does it work? So the current version is version, I think, 3 or 4 compared to 2014 one, because basically blocks kept making larger, and the quick and hacky ways I did things first didn't actually work when a block was like 1 megabyte or 2 megabyte now. Now it works fine. So I use PostgreSQL for storing all the data, which is nice, robust, strong. Redis for caching, to actually make it faster to download data and so cache it so that I don't have to download it again. InfluxDB for the time series data, because when you have 500,000 blocks, that's 5. If you zoom out to the all-time view, that you don't want to download 500,000 points. You don't really care about the 2 blocks that are 2 minutes away. And InfluxDB helps you with that, because it compared to PostgreSQL at least, it does all the math of, okay, I'll just sample all the points you need and give it back. And it works really well with Grafana as well. There's a really seamless integration. And as I mentioned, Grafana for displaying, which lets me write only the blockchain parsing bit and not the borrowing Like this has to look nice on mobile, kind of thing. And the source is Bitcoin Core for Bitcoin, C Lightning for Lightning, and then phase estimation is of course all the APIs. For the Bitcoin Cache, I use I think BlockCypher or BlockTrail, one of these. And before that, the older versions used to use blockchain.info. But the thing is, and I think I realized both using it and working on it is, it's not really, it's good for knowing your balance, but for analysis, it's not good for me because it's super slow to download all the blocks. And it's not good for blockchain.info either because that's a lot of CPU we spend on give you data that we could use for giving user balance data or that kind of stuff. That's I'll also talk about that later.
C Lightning presents data on all 3 Lightning implementations, right?
No, so it's just one of the Lightning implementations. It talks to all the other ones. I mean, it should. They do test on that.
It's showing you its view of the network.
Yeah. Oh. Actually, each node will have even with the same implementation, will have a slightly different view of the network because it's not a broadcast network. I don't remember exactly how it works, but not all the nodes have the same view of the network, which is fine. It's the same for the mempool data, for example. Not all the nodes have the same view, but over time it gets consistent. So if someone creates a channel, you can choose to not announce it or just announce it and then as a command line and online and offline it will get transmitted. Yeah, so PostgreSQL stores some information. The trick with analyzing a blockchain is to not care about the stuff you don't need to care about because it's a lot of data. Like even in the most efficient size, it's like at least 150 gigabytes of data, which is quite, at least for a hobby like me, it's quite a lot of data. So the thing is to just go at the time scale you care about, which is for me is the block. I don't really care about like sub-block intervals of time. It's too fast, and it's also hard because then you need to be online all the time to timestamp the transactions, which adds a bit of trickiness. So I only store 1 row per block, so it has the hash, the height, volume, all the metrics I can compute for that block. And since that block is immutable, once I compute it for 1 block, I'm done. I will also store all the pay-to-script hash outputs, because compared to the other ones, they have a bit more information, because at least when they are spent, because you have the information of, for example, if it's a 2 or 3 multisig, who signed between the 3 keys. That's an interesting information that I want to store. And I've not done anything with it now, but I could use it, for example, to see, for example, this address is used 98% of the time with these 2 keys, but this time it was used with these 2 other keys. Maybe it was a hack, maybe it was key rotation, that kind of stuff. All the pay-to-script hash addresses as well, because it's just also a quick way for me, okay, this address, what kind of, especially a few years ago, no Explorer were giving you the information of, is it a 306 multisig, is it a 4 out of 5? Nobody was giving this information. There's also the, so per script type is all the script types I mentioned before, like pay-to-pub key hash. If you just look, you can just look at per block, what this block contribute. Did it added coins to this script type or removed? Did it created outputs for this script type, removed? I have a small table to explain that later. Lightning channel transactions. So one row per lightning channel. One it was created between this node and this node. What value? I mean, it's only the announced channels. Like there's many more channels. If you have the Eclair app on Android, your channels will not be announced. They are between you and the Eclair node, and then their channels are announced, but not the inbounds. And finally, for the fork data, I just have a massive table with the pre-fork history, ledger, not history, ledger. And then I just, when someone moves their Bitcoin Cash, I tick the moved on Bitcoin Cash row and column, and if it moves on Bitcoin, I tick the other one. And just with that, we also learn a lot. By, okay, this person moved the Bitcoin Cash, but not the Bitcoin. So I know the Bitcoins are active, are owned, because the Bitcoin Cash moved in the same the other way. So that's why, for example, we know that there's at least 10 million Bitcoins that are active or owned or did not lost since last year, out of 16.5, which is, I think, a good deal. I was not expecting that much.
10 million on which one? Bitcoin Cash?
All of them. So that moved on any other site.
Oh, that's the number that has moved on at least one?
Yeah, on at least one.
Okay.
It's actually more than moved on any other of the two, because of people moving only on one side.
So there'll be some that haven't moved their Bitcoin Cash.
Yeah.
So there'll be a lot more than 10 million active.
Yeah, I mean, we don't really know because until you move them, there's no way, or I mean, if you sign something, there's no way to know if someone actually owns the keys. So going back to Redis, one of the challenges when you are not using an Explorer is that the Explorers do a lot of work for you. So a Bitcoin transaction is very not big because it has to be broadcast to everyone. So one of the tricks is to, when I spend a coin, I only refer to the previous coin I'm spending, but I don't put the information about what coin is it, what is its value. It's assumed that the full node has this information. It needs to have it to validate, so it can just fetch it from the database, which is fine. But when you have a lot of transactions and a block can spend tens of thousands of coins, you have to fetch them from all over the history of the blockchain. And if it's in a SQL database compared to Bitcoin calls LevelDB, it's much slower. So one of the tricks is to use Redis, which is an in-memory cache, where basically instead of having it sitting on a disk, even if it's an SSD, it's kind of slow. You put this data, the recently accessed transactions or created transactions in memory, because when someone creates a transaction, it's most likely that it will be going to be spent quickly. I think if you plotted the survival chance of an output over time, there's going to be a 50% chance, I don't know, but I think it's roughly in that scale, a 50% chance that this output is spent in the next day or two. So if you just have that in memory, which is not that big, it's like 10,000 times 100 blocks, so 1 million, I don't know, yeah. Or 10 million. It's not that big, and it helps a lot with speed.
You remove the cache by block height, or like when you?
I think it's a time, just time. Just like 1 day. Or so it's a time and or maximum size as well. For example, at the beginning of the year, a lot of people were spending a lot of coins. So at some point, okay, I only have. I told Redis I need, I don't know, I don't remember the configuration, but I only have this much memory, so I'm going to give you that and fit how many you can, or 1 or 2 days worth in it. So coming back to the storing only data per block, what p2sh.info all boils down, and all these years boils down to is this trick of just having for one block, and for each script type that was used in this block, used either for creating new coins or spending new coins, you just have to count, for example, this block, it created 382 p2sh scripts, and it spent 564. So the net impact of this block, if of all the pay-to-script hash outputs that existed, it decreased it by the difference between these two numbers. And it's the same for the value. And if you keep a track of this net change from block 0 to now, instead of having to count, I think, hundreds of millions of outputs, you just have to sum 500,000 differences, so 1 million numbers instead of 500 millions, which at the beginning I was not doing it this way. I learned quickly that since it's an append-only log of information, you have to quickly reach some tricks to reduce the size of the data you're interested in. Otherwise, you'll need a lot of money to just maintain a database which is efficient. And so we did the same trick for pay-to-script hash outputs. Unfortunately, I cannot compact them, but it's not that many. It's only, I think, 50 million. And it gives the chance, I think, to compute, for example, I want to see how many bitcoins were stored in 3 out of 5 multisig over the history. And instead of going through the 500 million outputs, or whatever the number is, you just have to go over the pay-to-script hash outputs, and with an index, for example, in a database, it's quite fast. I think it takes maybe 15 minutes to get this answer, where otherwise, I don't know how long it would take without these kind of tricks. So like the whole maintaining of this website has been a fight, which is now thankfully solved, between me and the blockchain about it just growing in size and me just trying to catch up and keep up. At some point, I think in 2014, 2015, you couldn't keep up with the block size. When I think back, it's like, how could I not keep up with it? But that's, I guess, what learning does. And now it only takes 3 to 6 seconds to process a block from just knowing about it to being done with it, which is quite nice. But it's only 3 to 6 seconds for like recent blocks, because then a lot of data is cached and available. If, for example, it shuts down for 2 weeks and I put it back up, it's going to be slower. Whereas at the beginning, it would take up more than 10 minutes, which then I'm just trailing behind the network. So the slow parts is always the database stuff, because it's on the disk, it's not in memory. It does a lot for me, but I pay that cost. For example, only index to have fast answers, you have to pay it one way, which is when you insert data, you pay that cost. But I've been working on I think what will be the final version, because how can it get, how will I need more than 20 blocks per second speed? But it is the trade-off is I have to maintain another database on top of Bitcoin Core to basically to do the work explorers do of putting the scripts, fetching the information and making this data sit together. It's I think the work BlockSci did with their database of putting the information that you will need in the same space and also on disk, but then many tricks to make it much faster. And also you can use the fact that you're only going to read one block at a time and you're going to read it sequentially. So you don't have to put the data all over the place as a normal database would do, because it doesn't know which order you're going to read stuff. So a bit of aside on forks.network, which is a child website, because it's running on the same code base and the same server of p2sh.info. So it was born after the Bitcoin Cash fork, where there was a lot of drama. Oh my God, someone moved 80,000 Bitcoin Cash. What is going to happen? And nobody knew as well, or really few people knew or looked at how many Bitcoin or Bitcoin Cash have actually been split. Because so as a bit of a explainer, when the Bitcoin Cash fork happened, they shared a ledger at block 478 something thousand. And from that point, the two ledgers diverged, with one history being Bitcoin and the other one Bitcoin Cash. And if you look at who had pre-fork coins, and you can see, okay, this coin moved on that side, this coin moved on the other side, this coin moved on two sides. All this kind of information gives you a lot of information. So the same trick, you have I think 55 million rows of coins that were not spent. So there's only 55 million pre-fork coins when it was created, when it was spent on each side. And then you can see, if I want to know, for example, these three coins have been touched since the fork. This coin, nobody touched it. Is it lost? We don't really know. But this person only moved it on the Bitcoin Cash side. So we know that someone has a key, and same for this one. And they only moved on the Bitcoin side, but we know they could move it on the Bitcoin Cash if they wanted to. Of course, we can't know if it's ideological reason or just financial reasons that they don't move it or move it one way or the other. But it's interesting to know.
Can I just ask, I'm curious about whether I'm curious about whether that first category is large or not. I would expect the first one to be small.
Yeah, so there's more outputs than moved on the Bitcoin side.
Let me just explain my point. I was going to say that I would expect the first one to be quite small, because
I don't
a lot of people would think, right, I'm going to sell my Bitcoin Cash, or my Bcash, as it should be. I'm going to sell my Bcash, and but I'm going to move. A lot of people were talking about this very actively at the time, like, well, what I need to do is to move my coins first, and then the old one, it will be secure, like if I've got some weird client.
Yeah, so I think an interesting.
A lot of people would move the Bitcoin first, and then the Bcash would be moved after.
Yeah, so what people do would move the coins before the fork, and then after the fork.
Yeah, that's what I meant.
Yeah.
Well, before the fork. Oh, sorry. Yeah.
Yeah. So yeah, there could be an extra analysis of looking maybe like how many coins moved 2 or 3 hops after the fork, because some people moved just the coins to like a separate set of keys, just for safety's sake. Yeah. And some people moved the coins and sold them, and then these coins would have an history of their own after that, whereas the coins that were just moved for safekeeping and just like, we don't want to have cold storage for Bitcoin and Bcash, so we're just going to split everything. That would be an interesting addition to this. But if it's really similar of what happened, I think it's the reason why, because people move the coins on 2 sides at once. Like, maybe also an excuse to upgrade your cold storage or that kind of stuff. But you can still see bumps in it. And that was, for example, I think Gemini at some point moved all their coins in one go. Zappo moved all their coins in one go, which is kind of terrible, because now you know how many coins they have on each side. I'm sure a lot of companies are actually looking at this information.
How do you know they moved all their coins? Does that mean you knew in advance how many they had?
Well, the trick as well with the Zappo is that they use a specific multisig setup. Now they only, I suppose, 90% of the value in it. So when they move it, you know, okay, this is them. And also, like, there's they're not really privacy focused. I mean, you know, it's Zappo, so I mean, it's in a vault in Switzerland anyway. So good luck getting to the keys.
What's their fingerprint? Is that a 2 of 6?
3 or 5, what do you say? Yeah, I think it's 3 or 5. But I think BitGo also uses it, I'm not really sure. So they're not the only ones, but they're the biggest amount of money in it. So now a bit of the interesting charts that came upon for p2sh.info. This is the first one. I think it got p2sh.info on the radar of a lot of people, and also got it in the news, which is kind of nice. It was the Bitfinex hack. So in August 2016, Bitfinex got hacked in the middle of the night in Europe. I think there was like one day of people not knowing exactly, okay, they got hacked, but we don't know how many bitcoins were lost. And then someone, it wasn't even me, went on p2sh.info, okay, wait, there's a huge drop right at the time of the hack. And if we sum up everything, that's like 170 or 126, I don't remember exactly, like a lot of Bitcoin.
116,000.
Yeah, 116,000 Bitcoins that went moved right after, okay. So, and that's how the amount broke up before, like, it was out of their control. Yeah, I guess they wanted to keep the information close because that's a lot of money to lose. But it got out before they could control it, thanks or because of p2sh.info. Another one, which is actually the most complex chart, is the distribution. So the y-axis is how many bitcoins are in pay-to-script hash scripts, and the x-axis is time. And this is basically the history of pay-to-script hash, which was interesting. Like p2sh.info started here, and then it blew up. You can see, for example, this is 3 or 5. No, this is Zappo, I think, or someone that has a lot of money in 3 or 5. It's like 2 or 3, 2 of 2, and I'm sure you can guess from the chart when did Segwit activate, because you can clearly see at some point in time in August 28, 17, a lot of Bitcoin moved to pay-to-script hash because the easy version to implement Segwit, for example, the one the Trezor used, the one Ledger used, exchanges used, I think it's only Coinbase that uses directly Base32, used to use to wrap, since pay-to-script hash is so generic, you can pay to any script. You can also pay to a Segwit script, and people will still understand what it is. I mean, maybe not in 2014, not all websites knew what pay-to-script hash addresses were, but now everyone uses them. So that's where you can see when the Segwit happened. So you can have an estimate. We know how many bitcoins are in native Segwit addresses, the one that you know for sure are Segwit. But with that, you can also get a guess of how many bitcoins are in non-native Segwit addresses, because the green part is the one we don't know yet what type it is. Because when I send money to a pay-to-script hash, I only pay the hash, and an observer like me doesn't know what the hash means until someone spends from this address, and then you have to reveal what the hash, what the pre-image of the hash is. And from that information, you can know that there's, of course, as we get closer to the present, people move left funds less, so it will naturally be higher close to now. But we can still see that there's at least 2.5 million coins that move to pay-to-script hash addresses right after Segwit, which is an indication that there's at least 2.5 million coins in Segwit addresses, plus how many, I think it's like 200,000 that are in native Segwit addresses. So 2.7 million in less than a year, kind of good. Another one, so this is how many coins were split with Bitcoin Gold. And so this is a specific turning point. I think the chart is over 3 days. And there was an event that made people move a lot of Bitcoin Gold. And this is actually when Trezor released support for Bitcoin Gold. I think Ledger released support a bit earlier, but since a lot of people used Segwit at the time, I think I was one of them that moved to Bitcoin Gold, and it wasn't mined because no miners on Bitcoin Gold were mining Segwit blocks because, I don't know. But you can see, and that's also a very interesting factor, it is Trezor releases supports right here, and then right after that, at least, what, 700,000 coins move? So it gives us an estimate, even though without it, it would be really hard to know how many coins just out of the blue are in Trezors, but you can know there's at least 700,000 coins. And so it's a lower bound. It's certainly more than that, but how much, we don't really know. So what did I learn? Maintaining this website for 4 years, and so learning more about Bitcoin along the way. So the thing is, like, first general stuff, like sometimes you want to be a bit too pedantic and try, for example, to interpret the scripts in the Coinbases. It doesn't work. Miners can put anything in it. So I had a lot at the beginning, especially it was like parsing the blockchain up to block X and then it would explode. Okay. Fiddle a bit, it would go up to this block and then explode again. So I had to learn to be a bit more lenient and accept and learn from that, yeah, Coinbase scripts, I don't have to parse them because by definition they're invalid. So computing transaction fees, which on other explorers, well, it's just a number. Computing it is kind of hard because you have to fetch all the parents of the transaction, which could be from block, the last block or the block from 5 years ago or 10 years ago. So that's why I had to use a lot of tricks with Redis to cache and try to improve the performance. So one that is also, I think a lot of people don't know, is transaction hashes. Hashes are supposed to be unique. There's no collision, known collision of SHA-256, but some miners, so since a Coinbase transaction, the first transaction in the block, the one that pays out the miner, doesn't have any signature in it, so it's not unique. There's no uniquely, I mean, unless before B30, there was no unique information about this Coinbase, and some miner twice reused the same address and the same amount, this is 50 Bitcoin, in 2 blocks, which created 2 transactions, I mean, 1 transaction, which has the same hash, but present twice in the blockchain. So there's four blocks, which share 2 Coinbase each. So one block has Coinbase A, 2 blocks have Coinbase A, 2 other blocks have Coinbase B. And when at the beginning you do the naive way and assume that a transaction is unique or only appears once in the blockchain, you get bit. Fortunately for you, it's quite early in the history. I think it's block 90,000. So the first 90,000 blocks are tiny, so it goes quite quickly. But it's the first hurdle you have to jump through. So block times, it's a bit of a tricky one, especially when you represent time data. Instead of doing by height, you do by time. Sometimes you would have weird things where a value that is only supposed to go up goes down and up. What is going on? And actually, because miners are not forced to mine blocks to put the time in above the previous block. So the consensus is it's a long rule. Basically, you can not go back more than 2 hours or forward more than 3 hours. And then the real rule is what it calls the median block time is the time of your block has to be above the median of the past 6 or 12 blocks. I think it's 12. So this is the time you should use. If you have to assign a time to a block, this is the median block time. I think I only did it in the latest version. Otherwise, before there was some weird, if you look too closely, there would be sometimes where for example, the number of Bitcoins in Obreton is only supposed to go up or flat, but sometimes it would go the wrong way, and it was bugging me. So I would just use the median block time instead. So a full node, it's a lot of hassle to run. I mean, it's only going to get worse maybe, but it's much faster when you, for example, when I added the RBF replaced by free information, I had to look at all the transactions in the history all over again. And if you didn't care about this information and had done the downloading all the blogs from forks.network already, you have to do it again, which could take weeks or days, because we're not going to give you this information at like on a 1 gigabyte link, because that's a lot of money. So you have to download, and if it fails, you have to try again. But if you have used, for example, the Python Bitcoin blockchain parser library or any other tool, you can just read the files on disk, and it's much, much faster. Especially when, like me, you don't store all the information by default. You just store what you care about. It's much faster to use your full node. Hashing data, that's one I learned recently. Transactions, if you download the raw transaction, there's not the hash in it. So you have to hash the transaction twice to get the hash. But if you use the native Java or Kotlin function, you can get a 20% increase in speed, which actually getting the binary data, transforming it into a transaction object is quite fast. It's hashing it, which is slow. And if you use the libsec p256 k1 bindings for SHA-256, they did some C wizardry, and it's 20% faster than the native C library. It saves me, I think it saved me like 20 minutes. I mean, I spent 2 hours writing the stuff, but it saved me 20 minutes once, which was amazing. So Bitcoin D, at least when I started, there was only the JSON RPC API, which is basically a kind of old style kind of way of exposing data between services. But the issue is you are forced to use JSON, which is fine because you can read it as human, it's fast. But when you have to download, for example, a massive block, like a block which has 4 million weight units, and serialize it to JSON, to get it, unserialize it, it can take actually most of the time of the code you are doing. I mean, we're getting into the nitty-picky, but 500,000 blocks times half a second, it does add up in the end. It saves you days. So if you use the REST API that was added, I think, in 2015, 2016 to Bitcoin Core, it's much faster because they send you just the binary data. Just read the block of memory, send it to you, you put it in your block of memory, much, much, much faster. And finally, one that bugged me when I upgraded one version of p2sh.info to another one is I wanted to triple check that what I did was correct. So so I have all the unspent outputs. Let me sum them up, and I should get. And we are block 500,000. So from the block height, there's a formula to compute how many bitcoins have been mined, and it should match up, right? No, it doesn't match up, and it bugged me for a long time because actually some miners, along the history of the blockchain, forgot, or I don't know if it's forgot or why, but they could claim 25 or 50 Bitcoin, but they claim 24.99999 or 49.9999, and each Bitcoin was just basically never mined, and there's no way to get them back again. It's gone. There will never be 21 million. It will be 20.9 something. And it took me quite a while to understand. I thought, because of course I assumed I was wrong, because it can only be me. But triple checking. Okay, I'm not wrong. It's the system. Thank God I didn't spend 5 weeks on nothing. But it's always important to take what you know are guarantees, like 21 billion Bitcoin, all this kind of stuff. Like for example, Obliton only goes ever up, never down and up. To always triple check what you are putting.
RPC for that, because it's really annoying to try and work.
It's kind of slow.
Very slow, yeah.
Yeah, because he has to read like the 2 gigabytes of.
But it's even slower trying to look it up on the internet, which
blocks
have been.
Yeah.
You know.
Oh yeah, I mean this set will not give you which block did it. Actually, you have to do you have to do it manually. And I think. Oh yeah, so future work. So I have some information about the Lightning Network. I'm actually not creating as many dashboards as I could. For example, I could have the number of nodes, all this kind of stuff. But I'm trying to think of more powerful ways. There was a chart that I think Jameson Lopp tweeted a while ago, which was basically you take the network of the Lightning Network, and there's some graph theory metrics you can compute about it. And then you can see the evolution of this. For example, the centrality. There's many other metrics you can compute and then see over time how it changed. For example, I think one was the probability of routing a payment of $10 between, if you start a random node, you pick 2 nodes and you want to route $10, and it would be the probability of success. I think it was kind of low at the beginning, but this time, this kind of stuff, I think I could compute and display over time, okay, it got better or not, we'll see. So a work I did recently, which is with Nick Carter, which is the realized cap. It's a new way of thinking about market cap. So market cap is, there's 17 million Bitcoins. One Bitcoin was traded 5 minutes ago on Bitfinex at $6,000. So Bitcoin must be worth 17 million times 6,000. It's not how it works. It's not Apple where there's assets, there's hard stuff backing the system. It's just a game of trust. So you can have a better info. So the market cap is the upper bound of what the value of Bitcoin would be right now. The lower bound would be like how much money do the miners have invested, because they're going to make their money back, hopefully for them. And that's 10 billion. Market cap is like 110 billion, something like that. And in between is the realized cap, which is instead of pricing all the Bitcoins at the same price, so Satoshi's coin, which he never touched, never sold, are all like 1 million coins are worth like 6 billion now. You have to take information that at the time when they were mined and at the time when they were last active, they were worth 0. All the Satoshi coins, as long as it doesn't move them, are valued as 0. If I move 10 Bitcoins when it was worth $50, instead of valuing it at 60K, I value it at 5K. And if you do that for all the coins, you end up with a value of 80 billion realized cap, which is more reasonable.
Are you calculating the price at which that coin last moved?
Was created, yeah, exactly.
Or was moved, right? One of those two, yeah?
I mean, when you move one, you create another one and destroy the previous one.
Oh, I see what you mean. Yeah. Okay. I don't actually agree with you. I mean,
there's no perfect.
The lower limit is 0. Obviously, obviously people could decide it's worthless.
I mean, but I could buy a tiny amount of Bitcoin from you for any price, and it still give some value to it.
I don't think that like a coin that last traded in 2012 for $10.
The assumption is actually.
I don't see the logic there.
The assumption is also to find a way to discount or remove lost coins, and if you have coins from 2010 you never touched, congratulations, but I would have moved them first. So I assume that they are lost. Some people do move coins from 2009, 2010, but as a percentage of all the coins from 2010, the ones that move now, it's a tiny amount.
You're principally trying to account for the fact that some of them are lost and are not going to move.
Because if you, for valuing Satoshi's coins at 6 billion is wrong, because we know that if he moved it, when he or she or them move it, it's going to tank the market. Because what is going on? So valuing it at the fair market, and also the market price is just weird because there's no way you can sell all the Bitcoins in the world at the current price. It's just, and the current price actually is also a bit of a fallacy because it's not the current price should be the order book, not the last traded price. Because the book could just move down and down without any trade. It is technically possible. It's really rare, but it could move down without any trade. So, yeah, that's it. If you have any question, you can move to the Q&A answer. And thanks for your time.
Questions?
So to communicate to the Lightning nodes, you mentioned that you developed like a REST API to make it. Yeah, so basically C-Lightning, I don't know why, but it exposes a JSON RPC API a bit like Bitcoin Core, but instead of using HTTP, it uses IPC, which is a Unix interprotocol. It's like a socket. You write to the file and it writes back into the file. It's a bit awkward. And it's not really helpful when you have the node running in one place and your server running in the other place, because I can't write to a file on a distant, I mean, you shouldn't be able to write to a file on a remote host. So I had to write a little bit of software that would do the expose an HTTP endpoint I could talk to, and then it would talk to the JSON RPC on the server. I think it's because they don't want to expose, you don't want to expose your API where there's like withdraw command to the internet. So if you use the socket, it stays in the machine. It's not exposed to the internet. But that's how I did it. But for example, LND doesn't. I think LND exposes an HTTP API. But the issue, I didn't use LND at the time because you had to use BTCD, the Go implementation, and I didn't have the disk space all the time to synchronize a BTCD from scratch. So I just used C-Lightning. But now it works fine, so I'm just sticking with it.
So you just stick with that, right? Yeah.
Yeah, because it was the only one you could. And now you can run.
Now you can do both.
Now you can do both, but I mean, I don't want to bother just switching.
So if I wanted to parse the blockchain to, I don't know, see how many transactions have 3 inputs, right? Yeah. So it's something you haven't previously done. What would the steps be from the work you currently do?
Oh yeah. So for example, the example would be, it was built. I think the most recent one was RBF. So I would have to. There's a 2-step process. One, I would write the code to track it now. So we say, okay, so from the time I deploy this code, I will have added a new column to the database, which is like RBF transactions or whatever it is. I create the code, so all the blocks before I deploy I have 0 or no or something, a placeholder. And after this point, they have the correct value. And then manually on my laptop, I write some custom script to read the Bitcoin files and read quickly all over the history to compute it manually, and then put this data in a database instead of the placeholder, and then I'm done. Instead of having to do it on a server, I can do it locally. I can maybe serve it. I mean, I don't done it because it's not, the blockchain is not big enough yet. But you could, you do this part of history, you do this part of history. You could do over many machines and do it like in 15 minutes, like in less time it takes to write the script. But some metrics you cannot do that though. Like some metrics have a memory. Like if you want to compute the cumulative number of Bitcoin in p2sh.info addresses is fine. You have to know how many were in the block before you. You could get away with computing for each block and then summing the differences, but so most of the time it would be this 2-step process where I first track it for now and then compute locally the data for the history and then put it back in, so that at the end the chart looks nice and it gets updated as well.
You also alluded to like the movement with Schnorr and various other technologies as well.
Yeah. So for example,
not making it clear what type of transaction.
For example, if Schnorr would have been used, or Taproot or Graftroot, which one? So basically, it's one of the changes that make any script look like any normal signature. This chart would not exist, and actually it would be great because there's a lot of.
Well, things like Taproot, you're going to still have the non-cooperative cases.
Yeah.
It's going to look non-standard, but anytime there's a cooperative signing, it's just going to look the same as anything else.
Yeah, but then you can, even if you have this chart for the non-cooperative state, you cannot assume anything about the repartition of the cooperative one, because it might be that this company that uses 3 out of 4 is actually way more contentious than this company that uses 2 out of 3, but you will never know.
Yeah.
And actually, if you look at this data, you can see, I mean, not here, but after the Bitfinex hack, you can see them moving the rest of the money out of the, I think it was Bitcoin that we're using, to someone else, or I think adding another key, or you can also see people rotating keys. If you have a 3 out of 5 millisig, and it's the 5 board members, and you fire a board member, you have to rotate that key, because otherwise, this person could collude with 4 instead of 5 people to get the money.
Is that a dip? Like it's summer 2016, so it fits.
Yeah, it is. I think it is. Yeah. Yeah, I think they moved it because the hacker didn't put it in a p2sh hash address. Actually, if the hacker had stolen the money and put the money in a
used the
ordinary address. That's why you could see the dip. Otherwise, it would have been much harder to quantify the hack because you would have to know which addresses are Bitfinexes, which you didn't. But with this kind of heuristic, you knew it. So tip to hackers: if you hack someone, use the same address type than the exchange. Is less visible.
But this is all intimately connected with the story of the hack, isn't it? Because the story of the hack is the regulators came along to Bitfinex and said, no, this is no good, you have to like separate and like...
Or segregate user funds, yeah.
And so they came up with this cockamamie, like stupid system with BitGo involving having a multi-sig.
But there was no guarantee,
The procedures were completely screwed up with that multi-sig, and so they lost it. They were basically hot wallet multi-sigs. It was just nuts.
If it was proper multi-sig, like all the other ones, we didn't find, but... It actually was a big, I think it's not clear yet, like they were supposed to make an audit or something like that about what happened, and
nothing came out.
Nothing came out.
No report,
But from the blockchain you can see what happened in the days after when they moved the money into, I don't know, I suppose it was them, because who moved so much money right after the hack? Maybe it would have been other Bitcoin customers, I don't know. But
did everyone understand that? I don't know what happened after that.
So a few days after the hack, you could see a lot of movements in these kind of, so like 3 out of 5, 3 out of 6, 4 out of 6.
Oh, so that was them kind of after they...
Yeah, like I think I don't know for sure, but I suppose it's the aftershocks of the Bitfinex. Okay, we need to add one more signer. Or okay, we'll keep the hot wallet multisig as it is, but we add another key somewhere else. And so we go from 3 of 5 to 4 of 5, or 3 of 6 to 4 of 6. And there were some of these changes in the days after the hack. And also another information, I think I did a blog, an article about that a few months ago. Is some setups are so exotic, like 2 out of 6 or 3 out of 7, that if you just look at it, you know, okay, this is a hot wallet, goes to cold storage. If this is a balance, you can see what is happening, and you lose, I mean, maybe you don't care, but you lose a lot of privacy if you use these kind of setups, and you're the only one using 2 out of 3, if you're the only one using 12 out of 14, there's no one, you lose all the privacy, because even though you make a chain of transactions which you could break the same input heuristics and all this kind of stuff, you're still the only one using it. So
it's the most obscure multisig.
actually, I did a number of, because so you can do from 101 to 15 of 15, there's like 120 something combinations, and there's only, at the time, there was only like half of it, or 60% of all the combinations that have ever been used. And I think there's some that are used by only once, there's like one coin in it. Or there was one coin 2 years ago and then he moved away.
So pre-SegWit, 15 of 15 is like a technical limit, but wasn't there like didn't it end up where like the standardness limit ended up meaning you couldn't really do more than 3?
No, so the standardness limit is on the script size.
It didn't end up meaning
but,
it's 3 of 7.
But then if you do the math, it's 15 of 15. So the script size is like...
15 is on the standardness or the...
So the 15 is not actually, it's not a rule. The rule is the script that hashes to the hash has to be less than 2,600 bytes or 1,600 bytes. And if you do the math, okay, the maximum I can fit, there's a bit of, I think there's a bit of leeway, is 15 out of 15. But maybe it has to using compressed keys and all this kind of stuff.
Right. There's a lot of details, yeah, I remember.
Because also another one is, when I say 2 out of 2 multisig, you can get a bit more metadata if you look, for example, one key is compressed, the other key is not compressed. Ooh, that's interesting. That's a super exotic setup. I wonder who is using it. I haven't done the thing, but that's another step. You could go and learn a lot of information just by looking at that.
So just to maybe we could explain to people here, because I'm
for
everyone knows the implications of both Schnorr and possibly Taproot here. So the implication of Schnorr in the simplest case is that if you had an n of n multisig, so a 3 of 3 or a 4 of 4, very simply you could replace it with a single signature, so it looks the same as 1 of 1. There are also like more complicated exotic plans to allow people to do n of m, so not the same number of keys as signatures. Using Schnorr, again, it would end up with a single signature, right? Taproot's weird because what Taproot's saying is that even if you have a complicated like contract, if the two parties, when the coins are going to get sent, or two or more than two parties, when the coins get sent, agree, then they can just publish the output without exposing the whole contract. So, like with these, you have always, if you're ever going to spend any of these coins, you always have to publish the contract, which says this is 2 or 3 multi-sig with these 3 public keys.
Or it could be like a more complex, like these 3 keys, or these 4 keys, or these 5 keys.
Yeah. So with Taproot, you don't, as long as there isn't like a dispute, and then you have to settle it by actually publishing that script. If there's no dispute, you can just publish a single signature, and it looks like everything else. So it's all this.
There are some downsides. So like there's interactive key setup.
Yes.
You don't know.
Is it
interactive key setup with multi-sig already?
Yeah, you have to build the script beforehand to be able to pay to it.
Which is one of the main reasons ordinary people don't use it.
And actually, that's it's also like considerations. For example, some websites, like even you can go really deep, like the key ordering. Some services order the keys in a way, some the other way, some don't order.
Some use lexicographic, some don't.
Yeah, exactly. So even a simple multi-sig transaction has quite a lot of depth to it. There's the multi-sig setup, ordering of the key, compression of the key, and then who signs? Like 2 of 2 is not, like 2 or 3. Is it the first 2 keys that sign, or any like a weird combination of the keys, or the last 2 keys? All this kind of stuff has implications.
Are you familiar with how Chainalysis do their work? And if you,
I guess even if they were smart, they would do that, because instead of just being like 2 out of 2, we can go deeper and say, okay, how many addresses use 2 out of 3 where the first 2 keys signs and they order lexicographically? I mean, if you know these services uses that, you can reduce the amount of work you have to do by a lot. So that's why standards like from BIP69, which there's a chart of, which basically says when you create a transaction, there's a way to order the inputs and the outputs, so that you don't reveal. I mean, you reveal how you order them, but it's the standard. So you should use it. There's actually 70% of, I mean, either by default, by design, or by accident, because just sometimes the ordering just matches up. Use this standard, and there should be maybe one for multisig, where you say, when we say, when you create a multisig setup, you order the keys lexicographically and you use compressed keys, and that would remove all this information that you are leaking otherwise. If there's no standard, you're leaking information.
So with the implementation of Schnorr and Taproot, would Chainalysis be able to continue to do what they do with law enforcement, or would that?
Well, there's still a lot of heuristics. I mean, if you, for example, text someone an address and say, hey, for the weed money, you're going to get in trouble anyway. Like, Taproot is not going to help you. But, and there's also a lot of analysis about the graph. Like, for example, if I pay you and you pay him, I mean, it looks like that on the blockchain, and it's most likely the case. Some people use CoinJoin, but it's not everyone yet, and there's not technology like a Mimble style of where we aggregate all the transactions, or we to basically hide the transaction graph, which is still available to these companies, even with Schnorr. That there's less information, but there's still some information. But I don't know how we could do it to hide the transaction graph, and then it would just be, I can't do any work anymore. I have to shut down. But it's quite a bit of work for that.
So 2 of 3 multisig has been the most popular.
Yeah, I think it's the default, like for maybe GoPay and BitGo, and even for exchanges, like just 2 keys, like 2 servers and 1 key in some safe somewhere. It's also so when you're using multisig, you have to be considerate of, if I use 14 on the 15 because I'm a snowflake, you have to pay that cost at some point, because when you reveal this, every time you spend the script, you have to reveal the 15 keys and the 14 signatures, and when the fees are $10 per transaction, you don't do that. You use Segwit, you move to like 2.2, 2.3, or even ideally if you use 2.2, you move to, one day you move to Schnorr, and then you just got all your cost by half. Or you use batching and all this kind of stuff. But that's only, maybe one day we'll see actually all these setups gradually. So if one of the fees go really out of hand, we might see, or maybe not for 3 or 5, because all these is actually maybe like 200 addresses, so they can afford to pay the fees, and they don't move them that often. But otherwise, you might see actually like 2 or 3 is too expensive, and it was the case in December last year, like, well, I'm not going to use this wallet, I'm going to use this wallet because they use normal addresses. I lose a bit, tiny bit on security, but I save like $20.
With Lightning, has there been a big increase in the use of 2
Actually, good point. I don't think there has been, but actually I could look into it, yeah. Because it would be SegWit 2 actually, yeah, but it is...
This graph shows nested, SegWit, multi-sig, but it doesn't show...
But it's too small that it doesn't...
P2 native.
No, it does.
Which is very small, right? Oh, it's on there, but it's very small, right?
Yeah, P2, so there's SegWit. The only one that actually pops up is the pay-to-witness script hash.
No, but that
says
the
amount that's held in them, not because of the amount of them.
Hmm?
Is that just the amount that's held in them, not lots of them?
Yeah, there's...
But I looked at this before, that says pay-to-witness pub key hash, it doesn't say pay-to-witness script hash.
Oh, this one...
So it must be nested.
Yeah, this one is nested pay-to-witness pub key hash.
Right, gotcha.
But there's also pay-to-witness script hash, which is the pay-to-script hash, but natively on SegWit, which saves you quite a bit of fees. But actually, not a lot of people.
It's tiny.
It's tiny. Yeah.
Bitcoin and the Lightning Network as a whole, it's going to be
Yeah. It's going to be tiny. And actually, they would more likely be in the green part, the unspent part, because they are inner channels, so they're not closed yet. But since people cycle through channels, yes, some of it are somewhere in this chart, tiny 1 pixel.
So you've written some great Medium posts. I was reading before this. One of them on non-standard scripts. What are your views on some of the non-standard scripts that
the opcodes?
They might be.
Oh, I don't have the list ready, but there's some that are disabled for good reasons because enabling them will be opcat concatenation. If I create like a 4-byte array and do opcat, cat, I get 4, then 8, and 16, and at some point you have to stop allowing people. So opcat was just I take 2-byte arrays and I concatenate, and with a bit of logic, even there's no loops in strips, you can still use a lot of memory. So some of these opcodes are disabled for these reasons because it's really hard to enable them in a way that you can still use them, but also know when not to use them. It's a whole like Ethereum gas situation where you can do whatever, but we still have to limit the resources you use. And it's like the Turing completeness, or there's some weird and really hard fundamental questions, problems that you cannot know upfront by just looking at a program, how much resources you're going to use. And there's also some opcodes that are disabled for, I don't know why really. There's like some mathematical operations like XOR and that kind of stuff. Maybe because it's concerns about how to do the math in a proper way. I don't know exactly.
Doesn't seem like anyone knows why some of them are disabled.
Yeah, they want to say. Yeah.
Disabled them, so it's Satoshi's vision, right?
Yeah, yeah. But it's interesting. Actually, but even with the ones you can use now, there's some really interesting ones. There's one with a simple equation like x plus y plus z equals something, and there was one solution someone used it. I don't remember. It's been so long. But it is. I should look into it if there's been more that have been published. Recently, there was one, I think it was Peter Todd that did it. Well, I think he committed to some text, and there was some, I don't know. But yeah, there's some funny one. And then you can, actually with all these Lightning stuff, there's been a lot of people thinking about how can I make more complex scripts, and we might not see them in the non-standard because they would be hidden inside the P2 script hash stuff, but that's interesting.
Any other questions? So I'll do one last one. Can you talk to us about your contribution to Bitcoin Core?
Oh, yeah.
The experience.
Actually, the path...
I saw you had a few untested apps.
Yeah, no, it's been merged actually. No one tested it, but it's quite a trivial change. So the history behind it is a bit funny actually. I was doing some exploration about basically Bitcoin, Dogecoin, Litecoin, and maybe some other coins, very similar. So what if I could do the same website basically, but on the other chains, but no one knows what is happening on Dogecoin. I don't know if no one cares, but I do a bit. I'm just curious. I want to see. And so I looked in Dogecoin, and it's such an old fork and so unmaintained. Like no one maintains it. That it doesn't have the REST API. Oh no, it has the REST API, but only some parts of it, and not the most recent ones. And one thing it was missing was getting the headers in JSON kind of thing. So I added it in the code and noticed, wait, there's some inefficiency. Basically, when there's a call in Bitcoin Core, I want to get the 2,000 headers after this block. It works fine, it's kind of fast, but it would be, the logic would be, I get a block in binary, the headers in binary. If you want it in binary, I just send them. If you want them hex encoded, I hex encode them. And if you wanted them in JSON, I just discard the data I just got and do something else, which you could optimize to save a bit of, I think it saves like, I don't know, a few seconds if you download all the headers, but I think every bit matters. And for the review process, I just submitted a pull request. I talked a bit to p2sh, which worked a bit with the blockchain about all the Bitcoin Core stuff, just to see, okay, how should I do it? Because should I try to minimize the changes I do, or should I try to, because the idea was basically, do I do a bit change bigger, but I would touch more code, or just keep it simple with a bit of code duplication? I chose to keep it simple for review because it was quite trivial to review, thankfully for everyone. And then people reviewed it, think, okay, that's fine, merge it.
So there were conversations that weren't obvious on the pull request. So I mean, I just looked at the pull request.
I don't remember.
Like 3 or 4 untested acts.
Yeah, yeah.
That's about it.
Yeah.
But there were conversations where you were getting informal acts.
Yeah, yeah. So it was because since the change is quite small, just taking a piece of code, copy pasting. Instead of having it in one place, I just copy paste it in 3 other places. I think it was deemed small enough that it doesn't need a. And this was
it just isn't really that. Like security really good or something.
Yeah, and it's also used the REST API. It's not like change the signature consensus stuff. So if it breaks, I mean, it passed the test. So I assume it was tested. Actually, I could have added more tests. I should have. So it passed the test. It was a trivial change, I guess. It was like, that's fine. If it breaks down, I guess they would find someone to blame. That was me.
So Michael, if you submit a typo PR, I'm going to...
And this is a CK.
15 tested acts.
Tested act. Actually, it makes a new line go.
Okay, last one. I saw you forked Rust Bitcoin. Do you have plans?
Oh yeah. So actually, when I was looking, I got really nerded a lot on how to parse a Bitcoin blockchain fast. So I first did it in Python, which is fine, but at some point it gets slow. Like, I want data now. I don't want to wait for my laptop to get hot and just have to get a coffee. I just want a number. So I first moved to Java, which is much faster than Python, but we can get better. And Rust is kind of this new, it's like a few years old programming language, which is basically C++ but modernized. Like, if basically we had to invent C++ without having to do C, and with all the advances in type theory, all this kind of stuff, it would be Rust. It is Rust. So I looked into it. I'm still not far from mastering all of it because it takes a bit of investment to master. Like, it uses quite a lot of fancy type theory to have guarantees about the code you write, but also be fast. So you have to master that. It's a bit different from all the other languages, which can basically do whatever you want, and then someone picks up after you. But in Rust, it has to be the picking up what you do is done at compilation instead of runtime. But yeah, look into it. There's I think Tamas Bloomer is also writing basically a database for Bitcoin stuff in Rust, which should be much faster. And once it's released, I think it should be soon. Could look into it and how could I use it to get even more speed.
Cool. Well,
yep.
There's no other questions. Thank you very much.
Yep, thank you.